right, let's finish up Mod 24 with some general information about confidence intervals, starting off with some Did I Get This activities on page 160. Suppose that the mean hours slept per day among a sample of college students was 7.1, so that would be our X bar value. A 95% confidence interval for the population mean hours slept was constructed. Which one of these could it be? Well, let's just remember how a confidence interval gets constructed. Our X bar value of 7.1 should be in the center. We move out to the right to get the right-hand endpoint. We move back to the left to get the left-hand endpoint. So, well, A just won't work, right? Because it has our sample mean, which should be the center, as the left-hand endpoint. So it can't be that. Let's take a look at the next one. If 6.9 is in the center and if 6.9 is the left-hand endpoint and 7.3 is the right-hand endpoint, is 7.1 in the center? And well, yes it is. It's perfectly. 6.9, 7.0, 7.1, 7.2, 7.3. Perfectly in the middle. So this is definitely a possibility. Let's just look at the last one. If 7.0 is the left-hand endpoint and 7.3 is the right-hand endpoint, is 7.1 in the center? Well, no, it's not, because 7.1 is closer to 7 than it is to 7.3. So this one also does not have our sample value in the center where it's supposed to be. So our choice is B. Number 6. Suppose that based on a random sample, a 95 confidence interval for the mean hours slept per day among graduate students was found to be 6.5 to 6.9. What is the margin of error? Okay, so this is about means. We know that our sample mean would be in the center. Off to the right, our right-hand endpoint is 6.9. Back to the left, our left-hand endpoint is 6.5. And we know that each of these distances from the center to the endpoints is one margin of error. And honestly, that is regardless of the level of confidence. No matter what the level of confidence is, the distance from your sample value at center to either of the endpoints is always the margin of error. So how are we going to figure this out? Well, we know the total distance across this interval is 6.9 minus 6.5, so that's 0.4. And then if we just divide that in half, 0.4 divided by 2 is 0.2. So each of the the distances on either side are, of course, equal. Each of them is equal to 0.2, so that is our margin of error. All right, last question here. This is a learn by doing activity, also on page 160. Each of the following situations, we're going to figure out if their conclusion is valid or invalid here, or their process. So let's take a look. In order to estimate mu, the mean salary of high school teachers in a certain state. So salary is our variable. High school teachers in a certain state is our population. A statistics student selected a random sample, that's good, of 150 teachers. That's good, right? Because we need our sample size to be bigger than 30. Random sample of teachers from the state. Okay, we have a sample size greater than 30 of a random sample from our population. So this is a valid process to use for constructing a confidence interval. It would be a T interval, right? Because the student found the mean and standard deviation of the teacher's salary in this sample. All right, situation B. A medical researcher wanted to estimate the mean recovery time, so that's our variable, from open heart surgery for males between the ages of 50 and 60. So that's defining our population. A researcher followed a random sample of 15 male patients in this age group. So this is a problem. Our sample size of 15 is less than 30. The only way we could proceed is if they tell us that recovery times follow a normal distribution, but they don't. The only thing they're telling us is that we've got the mean of the 15 patients was 26 days, okay? If they told us that the mean recovery time from open heart surgery has a normal distribution, we could proceed even with this small sample size, but they don't, so this is invalid. We cannot proceed. Situation C. A statistics class wanted to estimate the height, so that's our variable, of all male students at the college, so that's our population. They chose a sample of 35, that's good, it's bigger than 30, male students playing basketball in the gym one afternoon. This is not good, right? This is not a random sample, so there is no way we should proceed, and this is invalid.